Hello there, let's learn everything we can possibly learn from Apple's documentation on VisionOS. Here we're going to understand a RealityKit modular architecture and learn how everything fits together in RealityKit. RealityKit is a 3D framework designed for building apps, games, and other immersive experiences. Although it's built in an object-oriented language and uses object-oriented design principles, RealityKit architecture avoids heavy use of compositions, where objects are built by adding instance variables that hold references to other objects, in favor of a modular design based on the paradigm called Entity Component Systems, ECS, that divides applications objects into one of three types. Following the ECS paradigm allows you to reuse the functionality contained in a component in many different entities, even if they have different inheritance chains, even if two objects have no common ancestor other than entity. You can add the same component to both of them and give them the same behavior or functionality. Starts with entities. Entities are the core actors of RealityKit. Any object that you put into space, whether visible or not, is an entity and must be a descendant of entity. Entities can be 3D models, space, a shape, primitive lights, or even invisible items like sound emitters or targeted values. Add components to entities to let them store additional state relevant to a specific type of functionality. Entities themselves contain relatively few properties. Nearly all entities is stored on an entity component. Nearly all entity state is stored on entity components. RealityKit provides a number of entity types you use to represent different kinds of objects. For example, a model entity represents a 3D model, such as one imported from USDZ or .reality files. These provided entities are essentially just an entity, with certain components already added to them. Adding a model component to an instance of entity, for example, results in an entity with identical functions to model entity. Next is add components to entity. Components are modular blocks that you add to an entity. They identify which entity a system will act on and maintain the per entity state that system relies on. Components can contain logic, but limit components logic to code that validates its property values or sets its initial state. Use systems for any logic that affects the behaviors of entities or that potentially changes their state on every frame. To add accessible information to an entity, for example, add a accessibility component to it and populate its fields with the information that accessibility systems need, such as putting the description that VoiceOver reads into its label property. Keep in mind that an entity can only hold one copy of any particular type of component at a time. So for example, you can't add two accessibility components to one entity. If you add an accessibility component to an entity that already has one, the new component replaces the previous one. Lastly, create systems to implement entity behavior. A system contains code that RealityKit calls on every frame to implement a specific type of entity behavior or to update a particular type of entity state. System uses components to store their entity-specific state and query for entities to act on by looking for ones with a specific component or combination of components. For example, a game might have a damage system that monitors and updates the health of every entity that can be damaged or destroyed. Systems typically work together with one or more components, such as the damage system might use a health component to keep track of how much damage each entity has taken and how much each one is able to take before it's destroyed. It might also interact with other components. For example, entity might have an armor component that provides protection to the entity, and the damage system would also need to use the state stored in that component. Every frame, the damage system queries for entities that have the health components and updates values on those entity components based on the current state of the app. If an entity has taken too much damage, the system might trigger a specific animation or remove the entity from the scene. Writing entity logic in a system avoids duplication of work. Using traditional object-oriented programming design patterns where this type of logic would reside on the entity class can often result in the same calculations being performed multiple times, once for every entity potentially affected. No matter how many entities the calculation potentially impacts, the system only has to do the calculation once. For more information on creating systems, implement systems for entities in the scene. And that is all for this particular piece of documentation. I think let's take a look at an entity, component, and system. And we're going to go back to diorama to take a look at one. All right, let me pull that up. So here's diorama. I was taking a look at the flocking component. Here we register this particular component to our and we have a flocking system register.system. Let me see what that function does actually. So it registers a particular component, makes it available, I believe. And here we set the flocking component for the birds. And using this component, we are able to seek for flocking component items and use the flocking system to make sure that these birds flock in the same manner. So the entity is the bird that we have selected. We have added a flocking component, and we use a particular system after querying all of these birds for the flocking system, and we're gonna update their location based on this logic that's given here in this system. And that's the ECS in a nutshell. It looks like we have some more time here, so let's read the next article. Designing RealityKit content with Reality Composer Pro. Design RealityKit scenes for your VisionOS app. Use Reality Composer Pro to visually design, edit, and preview RealityKit content. In Reality Composer Pro, you can create one or more scenes, which act as a container for RealityKit content. Scenes contain hierarchies of entities, which are virtual objects such as 3D models. In addition to helping you compose scenes, Reality Composer Pro also gives you the ability to add and configure components, even custom components that you have written, to the entities in your scene, and also lets you create complex materials and effects using a node-based material editor called Shader Graph. Let's launch Reality Composer Pro. When you create a VisionOS project in Xcode, it also contains a default Reality Composer Pro project named RealityKit content within the package folder, which is a Swift package. The RealityKit content package can include images, 3D models, and other assets like audio and video. The assets you add to your project go into RealityKit Content's RK Assets bundle, while your source code goes into its source directory. The package also contains a file called package.realitycomposer.pro, which is the actual Reality Composer Pro project. To launch Reality Composer Pro, double-click the package Reality Composer Pro file in the Project Navigator or open in the Reality Composer Pro button. If your project doesn't already have a Reality Composer Pro project, you can launch Reality Composer Pro directly by choosing Xcode, Open Developer Tools, Reality Composer Pro. For efficiency, store all of your RealityKit assets in Reality Composer Pro projects. Xcode compiles Reality Composer Pro projects into a more efficient format when you have built your app. When you build your app. Loading assets from a Reality file is considerably faster and more resource efficient than loading individual asset files. All right, let's go into that and take a look at opening up Reality Composer Pro. So one way was to open up this using the developer tools. And so where are developer tools? Here it is. Open it up and we have Reality Composer Pro. The other way is to go to your project, go to your packages, and click Open Reality Composer Pro. Orientate yourself in Reality Composer Pro. The Reality Composer Pro window has several sections. The top half display is the active scene. If you have multiple scenes, the window show a tab bar at the top with one tab for each open scene. A scene in Reality Composer Pro is an entity hierarchy stored in a USD-A file. The left side of the top panel contains the hierarchy browser, which shows a tree representation of the entities in the active scene. You can toggle it using the top left toolbar button to reveal errors and warnings. The main panel is the 3D view, which shows a 3D representation of the active scenes. The top right is the inspector, which shows configurable values for items selected in the 3D view, hierarchy view, or shader graph, depending on which has focus. Tip: a Reality Composer Pro scene can represent an entire RealityKit scene, and you can have multiple scenes in your Reality Composer Pro project, each driving a different reality view in the same app. A scene can also contain a collection of entities to use as a building block. For example, if you have an airplane model, you might have built a scene for it that contains its 3D model, a particle effect that makes smoke come out of the engine, and audio entities or components that represent the various sounds that planes make. Your app could then load these combinations of assets and use them together anywhere else it needs. The bottom half of the Reality Composer Pro contains the four following tabs. The project display all of the assets in your project. Shader graph, a advanced node-based material editor, audio mixer, a tool for combining sound assets, and statistics, information about the currently open space, such as the number of entities, vertices, and animation it creates. I think we should take a look at all of those and make sure we're clear about those things first. Let's open up Reality Composer Pro. Here's the hierarchy window. This is our diorama that we looked at very recently. This is our 3D view. This is our inspector. This is for, I think, the bird and the sound. So let's click this back onto El Capitan or the root. This is our root view, which is the hierarchy view. Here at the bottom, we have the project browser with all of our assets in the project, our shader graph. This is our node system for materials. We could see this probably for clouds or maybe not. And this is our audio mixer for audio. I think we can take a look at the spatial audio here. And this is our statistics. How many polygons we're using, or particles and geometry, triangles, vertices, meshes. Reality Composer Pro projects start with a single empty space called scene, which is stored in a file called scene USDA. You can create as many additional scenes as you need by choosing File New Scenes. New scenes open as tabs along the top of the window, and they also open in the project browser as USDA files. If you close the scene tab and need to reopen it, double-click on the scene USDA file in the project browser. If you no longer need a scene, delete its USDA file from the project browser and remove it from your project's RK assets bundle in Xcode. To delete a scene, close the tab, select the scene file, control-click the scene file, choose delete, and move it to trash. This removes scene USDA and the scene tab at the bottom, at the top of the window. All right, on to the next section. Add assets to your project. In Reality Composer Pro, you design scenes by first importing assets into your project. Then add assets to scenes and move, rotate, and scale them. The Project Browser tab displays all of the asset files in your project. You can add new assets by dragging them to that project browser or by choosing File Import and selecting the assets to add to your project. To add an asset from the project browser to the current scene, drag it into the 3D view in the center of the window or hierarchy view in the top left window. Let's do this quickly. And so Reality Composer Pro, let's make a new scene that we can just like throw away a little bit. Let's call it temp. This is tempo, temo, and let's drag in we imported a campfire earlier, so this is our campfire. Replace. So we have this campfire. We drag it into our scene. We drop it. It's enormous right now. Enormous campfire. So drop in 2 zeros or 1 0. Shrink the campfire to a tiny little object. And there, we scaled it. We can rotate it by 380 degrees if we want by the x-axis. And now we have flipped it upside down. Okay, 180 again, or 0. And I think this is the y-axis. So 180. What happens there? 90 degrees. Oh, this is the y-axis. About the y-axis. So it rotates it from the center. And this rotates from the x-axis. And this rotates it from the z-axis. All right. And with that, let's move on. Reality Composer projects can contain assets not used in any scene. Such assets are still compiled into your app and can be loaded at runtime and take full advantage of the efficient loading process for .reality files. Reality Composer Pro can represent many assets as entities, but it cannot represent all assets that way. For example, USDZ models do become an entity or entity hierarchy when you add them to a scene. Image files do not become an entity. Reality Composer Pro only uses image assets indirectly, such as being the source texture for materials you can build in the shader graph. If you drag assets that Reality Composer Pro can't turn into an entity, nothing happens. Add any 3D model, animation, sound, and image file you need to your project. You can organize your assets into subfolders to make the project browser more manageable as your project grows in size. Reality Composer Pro has a library of assets that you can use in your own app. You can access the library by clicking the Add button in the toolbar. Click the icon down and inside a circle next to an asset to download the asset to Reality Composer Pro. When the download finishes, you can double click and drag the asset into your project. Let's take a look at that. Here's our Add button. This is our collection of items. Here's the download button. Let's say we want to add a drum set to our scene. And so here we finished, once we finish downloading the drum kit from, we will be able to drag it in. I forget, I think this is collection scenes or something. There you go. There's a drum kit. It's enormous. And we can, compared to our little stick fire, our stick fire is pretty tiny. So we'll set it to 0.01. Or that's a little too small. Let's make it a little bigger. Here's our little drum set. 0.1 maybe. That's a little better. Next to our enormous pile of wood. All right. Reality Composer treats your imported assets as read-only. Changes you make to assets in a scene only affects the scene copy of the assets. The changes you can make are stored in the scene USDA file, not the original asset. That means you can work without fear of inadvertently changing other scenes if you plan to make significant changes to an imported 3D model, such as by replacing its materials with a dynamic shader graph material. Import the model as a USDC file instead of a USDZ file, and then separately import just the supporting assets you need to avoid Xcode compiling assets you don't need into your app. All right, next step, next part of the article, compose scenes from assets. All RealityKit entities in a scene exist at a specific position, orientation, and scale, even if that entity has no visual representation. When you click to select an entity in the 3D view or hierarchy view, Reality Composer Pro displays a manipulator over the entity in the 3D view. Any configurable value from the entity component in the inspector on the right, you can use the manipulator to move, rotate, and scale the selected entity. To move the selected entity around the 3D scene, drag the small colored cone that corresponds to the axis you want to move it along. Alternatively, you can drag the entity itself to move it freely relative to your viewing angle. To rotate the selected entity, click on the manipulator rotated control, which looks like a circle, and drag the circular motion. Reality Composer Pro manipulator only shows one rotation control at a time. To rotate the entity on one of the other axes, click the cone corresponding to the axis you want to rotate. For example, if you want to rotate the entity on the x-axis, tap the red cone that brings up the red handle for the axis. To scale the selected entity uniformly, click the rotation circle and drag away from the entity origin to scale up, or towards the entity origin to scale down. Because it scales uniformly, it doesn't matter which rotation handle Reality Composer Pro is showing. In the manipulator, red axis indicates X, green axis Y, and Z, blue is Z. All right, let's see it for ourselves. So the x-axis is the x-axis, is the red axis. So here we go in the x direction. This is positive, this is negative. Then we have the green, which is the y. It goes up and down, positive and negative. And lastly, we have the blue, which is the z-axis. As you can see, as I update the z-axis, it updates on the transform side as well. Now, we can also do rotations by going around the circle. See, this is around the z-axis. And if we click the green, we can go around the, we can go around this is, I believe, this is the y-axis. Of course, we have not set everything to 0 yet, so that's gonna be, let's reset that, everything to 0. So this should be the y-axis, I believe. The red is the x-axis, green is the y-axis. And so it's very difficult to manipulate here for some reason. And there it is. And red is the x-axis. This is very tiny. Maybe if I make it bigger, it'll be a little easier. Now this is the red axis, and if we want to rotate, we just spin it around the x-axis right there. I prefer this particular method instead. It's a little bit easier. And we also have scale, just command click any axis circle, and we can expand and, control click, and then we can open it up by expanding the earth or shrinking it. And with that, that's our demo for that bit of the Reality Composer. Activate and deactivate scene entities. Reality Composer Pro scenes can get quite complex and sometimes contain overlapping entities which can be difficult to work with. To simplify a scene, you can deactivate entities to remove them from the 3D view. Deactivated entities by clicking them and selecting deactivate from the context menu. The entity still exists in your project and is shown in the hierarchy view, avidly grayed out without any child entities. It won't, however, appear in the 3D view. Xcode doesn't compile the deactivated entities into your app bundle. So it's important to reactivate any entity your app needs before saving your project. To reactivate entity, control-click the entity in the hierarchy view and select Activate. So suppose we don't want this, and we hit the Control button, Control-click, and we want to deactivate it. Now this appears. Now we can just focus on our drum set. However, we want to bring it back because it will not show up in our scene when we animate this particular scene, and when we call for this particular scene, we will not have a campfire. All right, add components to entities. RealityKit follows a design pattern called Entity Component System, ECS. In ECS, you store data on the entity using components, then implement entity behaviors by writing systems that use the data from those components. You can add and configure components to entities in Reality Composer Pro, including both built-in components like particle emitter components and custom components that you write and place in the source folder of your Reality Composer Pro Swift package. You can also add new components in Reality Composer Pro and edit them in Xcode. For more information about ECS, read the previous article, Understanding RealityKit, Modular Architecture. To add a component to an entity, select the entity in the hierarchy view or 3D view. At the bottom of the right of the inspector window, click Add Components. A list of available components appear with new component at the top. If you select the first item, Reality Composer Pro creates a new component class in the source folder and optionally a new system class. It also adds the components to the selected entity. If you select any other item in the list, it adds that component to select the entity if it doesn't already have that component. Let's take a look at that. Here we have a drum set. Let's click the add component and we can give it a accessibility component, and we can say something about this component. So this is a drum set. Create or modify entity hierarchies. Reality Composer Pro scenes are hierarchies of RealityKit entities. You can change the relationship between entities in the hierarchy browser, except for parts of the hierarchy imports hit from a USDZ file, which Reality Composer Pro treats as a read-only file. To change the relationships between entities, or to create a relationship between two currently unrelated entities, use the hierarchy view and drag an entity onto another entity that you want it to be part of. If you want an entity to become a root entity, drag it to the root transform at the top of the hierarchy view. All right, let's take a look at that. Okay, here in our RealityKit Composer Pro, let's drag this drum kit to be under that of the fire, and or we can drag it outside of the drum kit and drag the fire inside the drum kit. Now this piece of fire, now it's one entity now. Now we move it together. No, okay, cool. Okay, next, modify or create new materials. When you import a USDZ model into a Reality Composer Pro, it creates a RealityKit material for every physically based rendering material, PRBR, that the asset contains. Reality Composer Pro displays materials in the hierarchy view just like it displays entities, except it uses a paintbrush icon. Reality Composer Pro doesn't display materials in the 3D view. The library in the Reality Composer Pro contains materials for several common real-world surfaces like metal, wood, and denim that you can import into your project. If you select a physically based rendering material in the hierarchical view, you can edit it using the inspector. You can replace images, colors, values for any of the PBR attributes with another image, color, value of your choosing. Any changes you make to a material affects any entity that's bound to that material. You can also create new materials from scratch by clicking the Add button at the bottom of the scene hierarchy and choosing Material. All right, let's see how that works. All right, let's look into these materials. First, what we're going to do here is pull in a sphere shape to take in our materials. Then let's go scroll down here. Here's one of the materials that we can find. This is a black silicone rubber. Replace. And now we have this particular black color here. We'll choose this material as the black silicone rubber. And now we have this black sphere. What we can do now is update the black silicone rubber to be a physically based rendering type color. And now we can start modifying the colors. Here we have a color picker. And let's make it a little bit pinker, give this a little green, give this a little blue. Nah, I should pull that back. All right. Oh, that looks fine to me. We have a nice little pink ball. Next, we have the roughness. If you just put up to 1, it's a very matte-like finish. If you put down to 0, you have a very glossy finish. Let's see what metallic does. So let's do a 1 metallic. Ooh, oh, wow. Looks like steel, 0.5 and 0. So we can play around with these opacities as well. So this is like making it more transparent, translucent. So 0.1 is like a balloon, more or less. This normal, I don't know what exactly this does. Let's see if this sets this to 1. Set this to 1. Set this to 0. Not really sure what's going on here with the normals. I will look into that later. I mean, more deeply. So what does 100 do maybe? Some bigger difference. Maybe that'll do something. We have a clear coat. Let's set this to 1. This gives it a little bit buoyancy. So, and there's a roughness to clear coat outside. It must be and there's a refraction, occlusion. We can look this up later. And yeah, that's it for materials. Let's get back into the next bit. Build materials in the shader graph. PBR materials are great at reproducing real-world surfaces. However, they can't represent non-realistic materials like cartoon shaders, and they can't contain logic. This means that you can't animate a PBR material or have it react to inputs from your app. Reality Composer Pro offers a second type of material called a custom material. You can build, edit custom materials using the Shader Graph tab. Shader Graph provides a tremendous amount of control over materials and allows you to do things that are otherwise require writing metal shaders. For example, for more information on writing material shaders, see metal. RealityKit doesn't represent Reality Composer Pro custom materials as an instance of custom materials, as you might expect. Instead, RealityKit represents these materials as shader graph materials instances. Here we have an example of a very complex material. This is going to be our diorama island land. The materials you build in this editor can affect both the look of an entity and its shape. If you build a node graph and connect it to the custom surface pin on the Outlook node, that node graph controls the surface appearance of the model and roughly equates to writing metal code in a fragment shader. If you build a node graph and connect it to the custom geometric modifier output pin, those nodes control the shape of the entity, which equates to a metal code running in a vertex shader. Nodes represent values and operations and serve the same purpose as either a variable or a constant or a function in metal. If you need the sign of a value, for example, connect the value output to the input pin of a sign node. Add new nodes to graph by double-clicking the background of the shader graph view and click New Node buttons on the right side of the screen. Some nodes like sign are universal and can be used with either output pins. Other nodes are specific to the custom surface or geometry modifier outputs. If a node name starts with geometry modifier, you can only connect it to the geometry modifier output pin. If the node name starts with surface, you can only connect it to the custom surface output pin. To unlock the real power of shader graphs, you need to be able to change values on the material from Swift code. Shader graph allows you to do this by creating promoted inputs, which are parameters you can set and read from Swift to change your materials at runtime. If you have a feature that you want to turn on and off, you can just create a Boolean input parameter and have conditional logic based on its value. If you want to smoothly interpolate between two colors, you might create a float input parameter and use it to control how to interpolate between the two colors. You can click on the constant node and select promote to turn it into a promoted input. You can also turn a promoted input back into a constant by control clicking and selecting demote. If you don't have an existing constant to promote, you can create new promoted inputs using inspector. The new input button only shows up in the inspector when you select a material in the hierarchy view, but have no node selected in the shader graph tab. To change the value of an input parameter from Swift code, use set parameters name and value and pass the name of the parameter and the new value. Note, the parameter name are case sensitive, so your name string must exactly match what you called the parameter in the shader graph. For examples of shader graph, see diorama and happy bee. And sure, let's do that right now. So here we have a beautiful custom material here for our diorama. And here is our promote value right here, progress. And with this progress value, we are able to interchange between Yosemite and Catalina. This determines the heights, the normals, and this is colors that we've chosen. And this gives it a mix between the two when it's switching between the values between Catalina and Yosemite, and gives us the proper material that we would like to show the surface. So let's take a look at that progress value in the code. This is the progress that we pull into a view model, and this is a material parameter name, the material we choose, and this is our slider. And this updates to be our slider value. Very cool, right? All right. I'm sure that there will be a lot of experiments that we can do using shader graphs, and I'm sure there's going to be more tutorials out there to look into that. But we're currently focused on learning more about designing RealityKit content with Reality Composer Pro, so let's keep moving. We have use references to reuse assets. If your project has multiple scenes that share assets, you can use references to avoid creating duplicate assets. A reference acts like an alias in a folder. It points to original assets and functions just as if there were another copy of that asset. Create references using the inspector. By default, the reference section is hidden for entities and materials that don't have any references. To add a new reference to an asset or material that doesn't have one, choose Reality Composer Pro Settings, uncheck Hidden Empty References. To add a reference, click the Add button at the bottom of the reference section in the inspector. Choose the USDA file for the scene that contains the asset. Then choose the asset you would like to link. After you do that, then the selected entity or material becomes a copy of the one you've linked. If you make any changes to a linked asset, those changes will affect every linked reference. Okay, let's take a look. All right, so a sample of a reference is a black silicone rubber for this particular ball. This thing we pulled in, this material, has a reference to this USDZ file. So if anything changes in this USDZ file, it will literally change our entity that we have here, and multiple entities that use the black silicon rubber USDZ file as reference. Right, a lot of these already, this has the reference to the campfire. And let's see about the drum kit. This has reference to drum kit. A lot of these things in our diorama does not have references. I believe the smooth concrete does have a reference and the base has a reference. But if we change those references, then that means that will update. Here's our bird audio. If we change the bird audio USDA, then that will also change our audio. All right, so that's with references. Next, preview scenes on device. If you have Apple Vision Pro connected to your Mac, choose Preview and Play, or click the Preview button in the Reality Composer Pro toolbar to view your scene on device. The Preview button is the leftmost button on the right side of toolbar, the one with the Apple Vision Pro icon. If you have multiple Vision Pro devices connected, choose which device to use by clicking the pull-down menu next to the Preview button. Let's take a look at that. I don't have an Apple Vision Pro. I think this is the icon right here, and this is send to device. I don't have a device, and nor do I have multiple devices. If you guys are lucky enough to have multiple devices, that would be send one to me. Uh, next, let's see. Next we have load Reality Composer Pro scenes in RealityKit. Loading a Reality Composer Pro scene is nearly identical to loading a USDZ asset from your app bundle, except you have to specify the Reality Composer Pro package bundle instead. You typically do this in the make closure of a Reality View initializer. Reality Composer Pro packages define a global constant that points to its bundle, which is named after the project with bundle appended to it. In the default Xcode VisionOS template, the Reality Composer Pro project is called RealityKit Content. The global bundle variable is called RealityKit Content Bundle. Here we are loading the biplane from the RealityKit Content Bundle. It is the same for a diorama if we pull that up. Let me just pull that up right now quickly. Where's our Xcode? And you see this is RealityKit Contents, and our bundle is going to be called RealityKit Content Bundle. And that's where we're pulling the diorama sample from. The code above saves a reference to the root node. This isn't required, but with Reality View, unlike AR View on iOS and macOS, you don't have ready access to the scene content, so it's often handy to maintain your own reference to the root entity of your scene in your app data model. When RealityKit finishes loading the scene variable contains the root entity of the scene you specified. Add it to the content and RealityKit displays it to the user. Great. With that, we have completed 2 articles today in our 8th video, or is it 7th? Well, I hope you enjoyed this video, and we'll be doing more soon. Next, we'll be doing capturing screenshots and videos from VisionOS Pro for 2D viewing. I don't think we're gonna skip this one, as we do not have Apple Vision Pro, and I don't think this matters to anyone yet without a Apple Vision Pro, which we do not have. So with that, we're done with RealityKit and Reality Composer Pro. And next time we'll be doing AR kits starting with Happy Beam. All right, that's it. I'll see you in the next one.